Hello, hello, testing, testing. Just waiting for everyone to get in. Let me just check something here. Right, this is the paper one scope. This is the paper one scope. What? What the hell was that? Huh? Was it you? Oh, the birds now in my ear. Anyways, let me just do a few alterations to the video. This is what we will be going through. Yeah. Number systems. This is referring to the paper we're writing in the Eastern Cape. Yeah. Let me just check if the audio is working as well. Yeah. Just check. Let me share the video as well. Okay. Share the video. Right. Let me just check out my sounds. I can't watch my own video, it seems. Just give me 1 second. There we go. 7 watching. Okay. Testing. Let me just check out my okay. Sound is perfect. Let's go straight into the first question. We'll be going over the provincial assessment from the Northwest Provincial Government, but it doesn't make a difference. It's all the same, regardless of the province. Just get my calculator here. Okay. So we'll be going over the paper one, June 2024. Please feel free to interact, to ask any questions, and to sway the video wherever you wanted to. So again, just to recap, we'll be going over question 1, number systems, algebraic and exponential expressions, algebraic and exponential equations and inequalities, parabola and straight line, and a parabola question. Okay, which this paper has for the most part. Okay, this is the June 2024, paper 1, grade 10, 75 marks, 1.5 hours. Okay, let's have a look at the first question. Are the following numbers rational or irrational? Okay, you're always going to get a rational or irrational question at the beginning, guaranteed, of the paper. That's just how it goes. Okay, let me just paste that here. So we have 1 over 3 pi. Okay, now we already know pi is irrational, and anything, let me just zoom that in, anything multiplied by pi or anything relating to pi, okay, would immediately be, right, that would immediately be irrational. Okay, we know that pi's digits, they go on infinitely. Okay, so this is irrational simply because of the pi. Okay, 1 over 3 pi is irrational. Okay, now we have 6 over 7. We have plus the cube root of 8. We know that the cube root of 8 is 2. We in grade 10, I'm not going to explain all of the small details, but we know that the cube root of 8 is 2. So we have 6 over 7 plus 2. We we can just put this into our calculator at this point because we're not meant to be solving this. So to save time, 6 over 7 plus 2, we have 20 over 7. Okay, sorry. Okay, so we know that 20 over 7 is an improper fraction. Okay, and we can just indicate that we know that to be rational. Sorry. Okay, so that is rational. Let us go to question 1.2. Okay, we need to prove that 0.04 recurring is rational. Now, there's a few things we need to know about this. Right? We'll start off with 0.04. Okay, we know that that's recurring. Then we're going to say let, okay, my handwriting won't be the best, I'm using a mouse here. Let x equal to 0.04 recurring. Now, there's two things here, right? I hope my video is playing. I hope the video is still fine, because I can't see so nice on my phone. Let me just check the quality quickly. My Wi-Fi is a problem on the phone. Okay, it's fine. So we have a problem here. Our problem is that the 4 recurring is after the 0. So we know two things. We can say we can multiply by 10. Let's start there. Let's multiply by 10. Then we're going to have 10x equal to 0.4 recurring. Do we see that? Now, when it comes to proving that this is rational, the key to this is that after the decimal, we need to have 0.4 recurring. So this is going to be our first equation, not this equation, simply because of this 0 here. So now we're going to multiply x by 100 for our second equation. So we're going to have 100x, okay, is equal to 4.4 recurring. Right? That is our second equation. Now, the key again to this, like I said, we need to have after the decimal point the 4 recurring. Okay? The problem here with this one is that it's 0.4. We want to have in the green, 4 and 4 recurring. Okay? So now we have these two equations where it is after the decimal point 4 recurring. We either multiply by 10 or we multiply by 100 after. Alright? So in this case, we needed to multiply. Normally, you multiply just by 10. Then you have x and 10x. Then you say 10x minus x. But the problem here again, like I said, is that after the decimal point, it's 0.4. So you want to have just the 4. That is why we also multiplied by 100. Alright? So we have then these two equations here. Equation 1 and 2. Right? Once we get to this point here, we are going to say equation 2, okay, I'm going to say 2 minus equation 1. So you're going to have 100x minus 10x, that's equal to 4 comma 4 recurring minus 0 comma 4 recurring. Okay. I think I sent something different in the group, but this is the correct one. Yeah. Then I end up with 90x is equal to 4 comma 4 minus 0 comma 4 recurring. The 4 recurring will cancel out, right? That will cancel with that. Okay. You'll be left with just the 4. Then to solve for x, you're going to divide both sides by 90. So therefore, yeah, x is equal to 4 over 90. But it can be so what if the question says we must state if it is irrational? What if the question says we must state if it is irrational? Are you referring to the first question, this one here? This one here. They normally have this rational, okay? Unless there's a test that it asks you to show that it is irrational, which it won't do. But if there is, send it to me. But for now, that it will always be to show that this is rational. Okay. So we have 4 over 90, but it's not done because it can be simplified further. That can be simplified to 2 over 45. Okay. I hope this question is a bit tougher to understand, but it's, yeah, if you did revision properly, or if you did study over some of these questions, you will get what I'm doing here with the 10 and the 100. So your final answer would be 2 over 45. Okay. Let's move on. And feel free to ask any other questions as well. This one is a tough one. Not a tough one, but you have to have some good understanding about your numbers. Yeah. Okay. So this is saying P is equal to x bracket 3x minus 2 over x squared minus x minus 6. Now, for which values of x is P equals to 0? Now, with this, we have to look at the fraction. They say P, right? What values will make P equal to 0? If I look at any fraction, let me bring up my calculator here. If I look at any fraction and I have 0 over 100, we all know what this is going to be. It is 0. So in other words, the numerator of a fraction, if the numerator of the fraction is 0, you still with me? That will mean that the entire answer will be 0. So in other words, this numerator over here, that numerator over there, if that is 0, then P will equal to 0. Like I just showed you with the calculator here. If the numerator is 0, the answer will be 0. So you need to find for which values of x will P equal to 0. From our knowledge that we just derived, we know that if the numerator is 0, P will be 0. So the numerator is x bracket 3x minus 2. If that entire numerator is equal to 0, P will equal to 0. So I create an equation saying that is equal to 0. Now, most of us will struggle to get what I just got here from the knowledge to answer this type of question. Okay, I've created that equation. Now, I have an equation here. Okay, this equation I can solve, right? We all should know the zero factor rule. I don't know if you can remember the zero factor rule, but when we have something like this in brackets, we have two possibilities. Now, if we look at this, we can say x is equal to 0 or 3x minus 2 is equal to 0. Okay, and we solve for x on both sides. For this one, it is already solved. Okay, then for the second one, we're going to take the 2 over and then divide by 3. So then x is equal to 2 over 3 or 0. So any of these two options here, any of these two, x equals 0 or x is 2 over 3, will make this numerator here in yellow 0. And if that numerator is 0, p will be 0 regardless of the denominator. So you can completely ignore the denominator. Okay, what you also could have done, you could have also, and I'm not going to fully do this one, you could have also said 0. So if p is equal to 0, you could say 0 equals to x, and you can say like this. See that? And then from this, I'm just going to make this in red or purple. You could have also chosen to do it like this, which is easier, but it's not faster. It's a bit longer, and we all need to know that we need to broaden our knowledge with the maths so that we can do everything faster. What is that now? Okay. So in the purple, you could have done it like that, and then you could have solved for x from there too. Okay. Yes. Okay, any questions on that? No questions? No questions. Don't be shy, guys. You can type in the chat. Don't be shy. Don't be shy. Don't be shy. Don't be shy. Otherwise, I'm gonna sing and I can't sing. Okay. Next, 1.3.2. For which values of x is p undefined? Now, I'm not gonna go further now. Someone needs to tell me what would make p undefined. Somebody must know this. What makes anything undefined? Please. Someone know this. I'm sure of it. I'm sure somebody knows. It's very simple, guys. Somebody, please. Let's see if we're ready for tomorrow. What would make p, which is that fraction there, undefined? Anyone? No one? Ish. I'll give you 10 seconds. 10 seconds. 9, 8, 7. Yo, guys. Ish, 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 ish. 5 seconds. Ish, 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 ish. Okay, it's fine. No one commented. What would make this undefined will be if the denominator is 0, right? So if we have 5 divided by 0, math error, which is undefined. What? What's making that sound? Maybe I'm being hacked or something. I'm hearing a bird. Anyways, okay, x squared minus x minus 6 if that denominator is 0. So in other words, if this here at the bottom, x squared minus x minus 6, if it equals to 0, this p will be undefined. So now we're going to sit and we're going to solve for x, because whatever x will be will make this 0, hence making p undefined. Now we have here a trinomial and we need to factorize. Whatever you do, guys, you can't skip factorization with your studying. It's everywhere. So we know how we solve this one. I'm going to put x here, going to put x here, okay. Then I'm going to choose either 6 and 1 or 3 and 2, but I see there that this is a 1 here. So 3 and 2, the difference between 3 and 2. And then now Kopat, you should say at least. But it's fine. I know you guys are too scared to answer now. In the fear of being wrong. But it's fine. So I'm going to choose 3 or I'm going to choose 2. Yeah? Now, that's a minus there. So I'm going to make the bigger one a minus and the smaller one a positive. Yeah, because this one, these two, minus 3 multiplied by 2 must give me minus 6. And then the middle term must be the difference here between these two. Minus 3 and 2 gives me minus 1. So now I have two brackets. I have x, excuse my x, minus 3, and I have x plus 2 equals to 0. Now, from here, I'm going to solve. Hey, what's going on? Two brackets. So that means I have two possibilities according to the zero factor law. So from here, I can either this equation I'm going to create, or I can create an equation from here. So then I have x minus 3 equals to 0, or x plus 2 equals to 0. Then I take this, I have two possibilities now. Yeah, I have two possibilities. Okay, two possibilities. So take that negative 3 over. I have x equals to 3, or x, I take the plus 2 over. So these are now my two possibilities to make p undefined. Okay, so if I have figured out which values of x will make p undefined, because I know that if this here equals to 0, then this entire fraction will be undefined. That is why I let this equal to 0. I solved it by factorizing because it was a trinomial. I got my two possibilities, and these are the two possible answers that could give that would make P undefined. Okay, any questions? No questions? Okay. Let's check to the next question. This one is going to be quick. Very simple. Determine between which two integers consecutive, very also important, sorry. Consecutive is two numbers that are following each other. But between which two, so square root of 12, between which two integers does this lie? So what I do is I do this for this type of question. Then I ask myself, which square root before and after 12 can I find? So I can find, remember guys, some of us, okay, I'm going to do the faster one, yeah? I'm just going to do the official one here. So square root of 9 before 12, I can find the square root of 9. And what square root can I find after 12? I can find the square root of 16. You see? So on the left, the smaller one, square root that I can find. On the right, one a bigger square root that I can find. Yeah. So then I can find the square root of 9. So it is 3 smaller than. Then you say square root of 12. And smaller than square root of 16 is 4. Alternatively, you can put on a calculator. Hey, what happened? Square root of 12 equals to ST button. See there? 3,4. So it is 3. And then the next number after 3 is 4. That's how you could have done it quickly on the calculator. But sometimes, you know, they give marks for this here. Sometimes there's a mark there. You see, to show that you are understanding what you're doing. But it doesn't say without a calculator. So yes, you could have just plugged it into your calculator. Whatever you find, if it was square root of 50, you see, then it would be 7 and 8 like this. If they said between which two integers, blah blah blah, square root of 96, you see there, then it would be 9 and 10. Okay, so for this one, square root of 12, that is 3, so it's between 3 and 4, and this is how you write it. Yeah. But if you don't have a calculator, if you want to know how to do it without a calculator, you can do this method here. You can find the square root of a number before 12 and after 12, which is square root of 9, which is 3, square root of 16, which is 4. And I'm over explaining. Okay, 1.5. I think I'm going too fast now. I'm speaking too fast. But you can put 0.5 speed, it's fine. Okay, this one. I looked at it and I was like, ah, but then I realized, calm down. Okay, minus 2 to the power of x, 2 to the power of x, 2 to the power of negative x. They say if x is an even integer and x is bigger than 1, you see, arrange the following in ascending order. So let me do this the long way. So it says if x is an even integer and x is bigger than 1, arrange the following in ascending order. Firstly, if we don't know what ascending order means, then we are already cooked from the start. But you know, ascending is from biggest to smallest. No, I know I'm lying. It is from smallest to biggest. Okay, so ascending smallest to biggest. You see how easy it is to mix it up when you don't think. Now, I have to find out which one of these will be the smallest. Now, there's two ways I can do this again. I can use my math knowledge just by looking at it and seeing which one will be small. Or you can substitute each x and you can say let x equals to, since x is even and it's bigger than 1, you can say let x equals to 2. And you can substitute 2 where x is for all of them. Then you can find which one is the smallest, which one is the biggest. Okay, so this first, okay, let's just do the first one. The first one, if I substitute 2 in the first one, so minus 2x, if I put 2 in there, this answer is minus 4. Okay, let me just, okay, then if I put 2 there, that's equal to 4 into the second one. Into the third one, 2 to the minus x, this would be 2 to the minus 2, which is 2 to the minus 2 is 1 over 4. Okay, just gonna skip. Then 2x to the 0. If I put 2 in x's place there, 2 to the power of 0 is 1. So that would just be 2. Do you see that? And then 2x to the 2. If I put 2 in x's place there, it's 4. 2 to the power of 4. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Yeah. So by the order now of these numbers, now you must arrange them in ascending order. This one here, because it is a negative number, will be the smallest. The next one, you can see this one here is a fraction. The rest are numbers bigger than 2. Okay, so this fraction 1 over 4 is 0.25. So I'm going to put this here. You understand? The next one would be this one here. Okay, because it's equal to 2. Yeah, the next one would be the one that's equal to 4. So it's 2 to the power of x. The next one would be 2, because it's 16, this one. Okay, so here's all my, this is what I'm looking at. And after I substituted 2 into each of them with the x, yeah, you can see which one is the smallest. You see by looking at what answer you're giving them. So when I substituted 2 into this first one, yeah, I got negative 4, and that's the smallest one. And I substituted 2 into all of them. And this is my order here. Ascending, smallest, the biggest. Factorization. This would be free marks for you guys. Free marks. This one is slightly tough to understand. Slightly tougher to understand. But it's just one more level above your level. Not even one level, but yeah. Okay. Factorize the following expressions completely. Leave your answers in the simplest form. Okay. Let me see. Can I just insert an equation? So I have 3ab brackets a minus 4 brackets minus 7a brackets a minus 4. Already we can at least see common brackets. What? What is that sound though? Maybe it's that ad. Oh, who's playing a wood? Is it you? There was a live stream of a flippin' pigeon in the background. Anyways, pigeon doesn't want to do maths. Okay, we have for this factorization here. We have 3ab brackets a minus 4, and we have minus 7a a minus 4. Here we have common brackets. So immediately I take my common brackets. Okay. Take my common brackets and I put them together, a minus 4. Yeah. In fact, let me start with 3ab minus 7a brackets a minus 4. Okay. So this is how we factorize common brackets, people. We just put the two that we have, that is the common. Do you see that? Those are two common brackets, right? And then we just put them as one, and then the other one that goes with it, we put it in the front. Do you see? Oh, the order doesn't really matter. So then you have those two over here, right? But we are not done, because look at this. Look at this. There's always that one extra mark that's gonna elude you or run away from you when it comes to factorization. There's common factors there. So common factors. Common factor. That means that a comes out there, brackets, then you have 3b minus 7, no, just 7, brackets, a minus 4, done. So that would be your final answer there. After taking out the common brackets, and then taking out the common factor of a in the second row there. Okay. Right. Then I put that there. Oh wow. Okay. Yeah. Okay. Next. Let me just select here. And I insert an equation. Now we have x to the power of 4. I don't know. We have x. Why is it highlighted? I could get this to the okay. Leave us. We have x to the power 4 minus 16. Now, when we have a difference of squares like this, if the exponent is an even number, we can also consider it square. Yeah. So also 16 is a square. So we can find the difference of squares here by saying x, and what you do with the exponent that is a 4, you half it. You half it. So it's 2 minus 4. Now remember, we make two brackets. The other one must be x2 plus 4. And you must always check. See, we factorize that. But you need to always check, isn't there any further factorization that we can do? And there is, because this again is still a difference of squares. Right? So then this is x minus 2 x plus 2, and you don't forget this bracket there, it always comes along. If you forget about that bracket, guys, you lose your mark, and that's what normally happens for the large percent of you guys. There you cannot do anything any further. That's your 3 brackets, that's your answer, your final answer there for that. Okay, right, no questions, nothing. It's fine, we move on. Okay, I'm just gonna erase. You can just pause it here. I'm gonna erase it now. I say. Okay, let's have a look now at this one here. It's a trinomial. Very, very difficult trinomial. Not very difficult, but it's now a problem that this is 6x squared. And for the most of you guys, you don't deal with any number in front of the x squared. But we have a 6 here. So using this method, right? I know that this is now my thinking process here. I know that this has to be 2 and 1. And since the middle term is positive, what is that? Since the middle term is positive, okay, and the last term is positive, when the middle term and the last term is positive, both of these numbers here are going to be positive. The problem on this side now, here on the left side, is now I'm either going to choose 6x and 1x, or I'm going to choose 3x or 2x. Do you see? Now, if I go across with 6x and 1, that gives me 6. There's 2 here. So the 6 and the 2 will give me 8. You see that? So I know that that is wrong. The 6 and the 1 will be out. So if I have 3x here, and if I have 2x here in this place, yeah, if I go across like this, when you go across, it must give you the middle term. So that is 3x. Nah? Then if you go across here, 2x times 2 is 4x. So if now, okay, so I can throw in yellow. I have 3x and I have 4x. That gives me the middle term, 7x. That is how I know that this is correct. Do you see? So now, when I draw my brackets, I look at the top 2. Yeah, I look at this and that. So I have 3x plus 2. There are many different methods to do this. I don't know, most of you don't probably use this method. And I have 2x plus 1. And that is done there. Okay? That is how you factorize that trinomial. Okay, moving on. Yeah, some nice ones coming up. Okay. Hope you can see that, guys. Okay. So we have x to the power of 3, y to the power of negative 2 times y to the power of 3. Okay, but let me just rewrite it. Nice and big. So we have x to the power of 3, y to the power of negative 2 times y to the power of 3, x to the power of negative 4, bracket to the power of 0. I just love it when it does to the power of 0. X to the power of negative 7, y to the power of 5. Now, something should immediately scream to you here. Okay? Something should scream to you about this. Why does it scream? I am not gonna ask. No one's gonna respond to me. This is going to be equals to any exponent that is 0, right? If the exponent is 0 and there's brackets like this here, and this 0 is outside of the brackets, as you can see there, everything inside the bracket is going to equal to 0. Okay, so that means I'm going to be left with the following. Okay, let me just do this. Okay, now let me not. I'm still figuring out this thing, guys. So I'm going to keep this here on top as it is now. Can you perhaps provide a past paper for grade 9 June exams? I did a grade 9 paper on my channel. Did you go through that video? And then if you did, I'll try to get you a link to the grade 9 papers. Okay. Now, we have x to the power of 3, that we're going to keep it like that, no? We have y to the power of negative 2, we're going to keep it like that for now. And in times, all of this is times 1. Okay, wait, let me just, I'm just going to draw a red line here just to separate. No? So, that entire thing here is equal to 1. Do you see that? Let me just also highlight it. It's equal to 1, this thing. So it's not going to make any difference. So now I'm just going to rewrite the denominator as it is. And I'm going to put equals to. Okay. When now I am dividing, if I'm dividing, I look for, firstly, the same basis. So I have x. Sorry about that. I have x in the top, x at the bottom. And I have y at the top, y at the bottom. So when I'm dividing, I have the same basis. So I know that I keep the basis as it is. And if I have the same basis, I simply subtract all of the exponents with that same base. Fortunately, we only have 1x on top, 1x at the bottom. So it's 3 minus the negative 7 that's at the bottom. Dot or multiply by y, that minus 2 minus the 5 that's at the bottom there. Okay? And that is what you have over there. You're not done. These two negatives will be a positive. So it's going to be 3 plus 7. So it is x to the power of 10 dot y minus 2 minus 5 y to the power of minus 7. Okay, for the sake of leaving our exponents positive, which is what most questions will ask of you. When you have anything that has an exponent to the negative, it always goes to make it positive, it always goes to the denominator. So now the 7 is positive at the bottom. Do you see? You could have done this differently as well, yeah, by taking those denominators to the numerator and changing the signs of the exponents when you do that. Okay, but our final answer, will still come to this or this. In the paper, it didn't say that you need to leave your exponents positive, but I'm just doing it because I can. Okay, moving on. Am I running out of paper? Oh. Ooh, this one. This one is gonna ruffle some feathers now. Because I know that when it comes to this, fractions and unknowns in the fraction, that is where the demons are coming from for most of you. Okay. In this case here, firstly, I factorize whatever you have at the denominator, you factorize it firstly. So let me do that. So I'm going to have 3 over, that is what difference of squares there. So x minus 2, x plus 2 plus 2 over x minus 2 squared. Now I have unknowns at the bottom, I have fractions. In this case, I'm going to find myself in LCD. Now, because it's not 4, 6, 8, 12, it's not even numbers or odd numbers, I'm going to take the fractions the brackets as it is. And because x minus 2 is already here, repeating, I'm going to take the one with the highest exponent. So my LCD here is x minus 2 squared, but also x plus 2. So this entire thing here is my LCD. And I know you're asking questions now. How come? How is this possible? Why did the resolution just change now? That is your LCD there. Right. Whatever you have at the bottom, it's always that your LCD. Okay? Even if you had something like a number, okay? If you had 1 over 4 plus 1 over 6, you could have your LCD to be this 4, 6. You can. You actually can. Okay? You can. But yeah, using that rule, this would complicate it. This would complicate the simple addition of fraction. But when it comes to this variables that's unknown and brackets here that's unknown, we take the common brackets, okay? And all the brackets that are existing by both denominators, okay? And the reason we don't take this one that I'm highlighting in green is because it already exists here with the other fraction. So you don't take it twice, you take the one that has the highest exponent over there. Okay. In fact, I'm going to explain this like you guys are asking questions. So what if it, can you explain that again, please? Okay, sure, I'll explain it again. So what if I have 1 over x plus 1 over x squared y? If I had something like this, what would be my LCD? My LCD would be x squared y if I had something like this. Do you see? So by both denominators, I see an x and an x by both sides. But I'm going to take the one with the highest exponent. Hence the same with this one here and this one here. I'm only taking the one with the highest exponent, and I don't forget about the other one. You see, like this here, this is like the y. You just bring it along. It's part of your LCT. Yeah? Okay. I don't think there's maybe any other questions beside that. So let's move on. Now that I have my LCT, remember this is not an equation. No? Short 3 no. Short. Remember this is not an equation. So you can't multiply both sides by LCT and get rid of your denominators at all. No, this LCT now becomes your denominator. You see? So it becomes a denominator like this. What happens now with your LCT is that you multiply this LCT. I'm going to highlight in green. This first term. You multiply your LCT by this first term. Do you see? And you multiply the LCT also by the second term. Do you see? So, what actually happens now when you do that? So, in red, the LCT is being multiplied. You multiply it there, you multiply it there. In the first term, nah, this will cancel out that one there, that will cancel out that one. I hope you're getting this, because this is, I know you are confused already. So then you have to 3 brackets x minus 2. Do you see that? I'm hoping that you see that. Okay, the cancellation that happened. When you multiply now, the same LCT, the same LCT, the same LCT, okay, it's fresh, so nothing is cancelled. The same LCD, now you can multiply it by this one over here. When you multiply it there, now this is going to cancel out with that. In this, you see that? That will cancel out. You'll be left now with just this one here. So then you have in the middle plus, because that's still this plus here, it's still forming part of the equation. Then this 2 here, remember that 2 still comes. Then you have brackets x plus 2. Okay. I just pray that you guys understood that. Okay. Then now we're gonna multiply in basics multiplied in simplify. So I have 3x minus 6. I'm multiplying in still now, plus 2x plus 4 over again still the same denominator. The denominator doesn't fall away. If you don't have the denominator, you're going to lose a mark. Please. Okay. So now you have still like terms on the top there. Just gonna highlight the like terms for you. That one and that one is like terms. So then I'll just write the final answer in blue. 5x, because 3x plus 2x. Minus 6 plus 4 is minus 2. All of that over x minus 2 squared brackets x plus 2 close bracket. Done. Done. I hope that we got that there. Let me just check something. Okay. I hope that you guys understood that. Okay, let us move on to the next question. Equations, easy stuff. Let me just take this. Okay, solve for x. We have 1 over 3x plus 1 over 2x minus 10 equals to 0. Again, we want to get rid of the fractions, so we're going to multiply everything by 3 and 2. So in other words, we can multiply everything by 6. No? So we're going to say 6 multiplied by 1 over 3x plus 6 multiplied by 1 over 2x minus 10 multiplied by 6. You must multiply every term by 6 equals to 0. Also multiplied by 6, but you know it won't make a difference there by the 0. Okay, so then you have here 6 times 1 over 3x is 2x plus 6 times 1 over 2x is 3x, because 6 times 3 is, for the first one is 2. 6 divided by 3, or 6 times 1 over 3 is 2. For the second one here, 6 times half is 3, and then minus 10 times 6 is 60. 0 times 6 is 0. Let me not ask the chat. Now, like terms, that gives me 5x equals to, I'm going to take the minus 60 over, becomes positive 60. Both sides. To find x, I divide it by 5. Divide by 5. 60 divided by 5 is 12. And we're not even using the calculator. 60 divided by 5 is 12. Okay. That one is done and dusted. Nice and easy there. Okay. Let's take the second one. Okay. Let me just enlarge it quickly. Now, our unknown number is at the exponent. And when our unknown number is at the exponent, we need to make sure that both sides have the same bases. Right? Now, earlier we learned that when something is at the new denominator, or our exponent laws tell us that. Okay, let me just refresh an exponent law quickly. If I have 1 over x, I can change it to be x to the power of negative 1. If I have 1 over x to the power of, just say 2y, I can change this to be x to the power of negative 2y. So it can be on the top there. So I can do the same for this 3 to the power of x. So I have 3x minus 2 is equal to 3, and now the x becomes negative. Okay, so now I have this here. And what's very, very important is that this base on the left hand side and the base on the right hand side is equal. When both bases are equal, okay, it's already done for us. When both bases are equal, we can take the exponents as it is. The left hand exponent is x minus 2, and you can say equal to the right hand exponent, which is minus x. Now you have here yourself a new equation there. Okay, that's the equation that we can use to find x. So we're going to take x to this left hand side. This minus x is going to go over. The minus 2 is going to go to that side, becomes a plus 2. Then x plus x is 2x equals to 2. To find x, We divide both sides by 2. Therefore, x is equal to 1. Okay, I went a bit fast there, but you guys are on that level, eh? Okay. Moving on to inequalities. Okay. I'm just going to rewrite this inequality again as well. Just rewriting it. Now, with an inequality, just going to work. Let's just go straight into it. I'm going to take the 4 over. It becomes minus 4 here. I take the if you take it over to the one side, it must be taken over to both sides. It becomes minus 4 there. So then I have on this side minus 6. Yeah. And I'm left with minus 3x in the middle still. 7 minus 4 is 3. And now you need to solve for x. Now there's a very important inequality rule that's going to come up now. Because to solve for x, we need to divide by negative 3. Now in inequalities, again you divide by negative 3 on all sides now, please. In inequalities, there's a very, very, very important rule that when you divide by a negative number, the direction of the inequality will change. Yeah? Look at this. So minus 6 over minus 3 is safely, it's 2. This inequality will change direction now. It's going to point this way. That inequality here is going to change. It's going to point this way. That is equal to minus 1. So this inequality, when we divide by a negative number, does the direction of the inequalities change? You see? And this is the answer, but we have to rewrite it like this. Okay? Because the inequalities must face. So we have minus 1. Then you can write it like this. There we go. Okay? You see, it's like you've just flipped the inequality. You put the minus 1 on the left and the 2 on the right. Okay? Because we must have the smaller number must now on the starting and the bigger number there. And then we flipped it around. Yeah? Okay. Yeah, let's move on to the next question. This could have been such a long simultaneous equation, but they made it quite simple. So, solve simultaneously. X plus y equals to 8. And this one is Afrikaans. It says in x plus 2y is equal to 21. Always choose your simplest one first to let x equals to, or let y equals to. So for this first one, I'm going to take that y over there. And I'm going to say let x equals to 8 minus y. That's going to be my equation 1. Okay. The second one here. Okay. I'm just rewriting that second equation. I'm going to call that equation 2. Okay. Then we're going to say substitute 1 into 2. So in other words, this equation here, x is going to go into this x there. See? And it's equal to 8 minus y. So then I have 8 minus y plus 2y, because I substituted in that x there. I substituted this 8 minus y. Okay, plus 2y equals to 21. Yeah, the y's I'm going to keep here, and I'm going to take the 8 over. So I have y minus y plus 2y is equal to y, 21, right? Then it's going to be minus 8 on that side. 21 minus 8 is going to be 13. Okay, now I have to substitute, because I found y, I must also find x. Substitute y equals 13. I'm going to substitute into, you can choose any equation, but I'm going to substitute it into equation 1, because equation 1 is very, very simple. Okay, so equation 1 is x equals to 8 minus y, and I know 8 minus y is equal to 13, so I substituted there. That's equal to minus 5. So therefore, x is equal to minus 5, and y is equals to 13. Okay, right, moving on. This is also a nice one. This is a nice one. Prove that. Okay, wait. Prove that. Let me just show you what it is. Bigger, yeah. It's cube root of x is equal to this. You need to prove this. Yeah? Now, we see that the right hand side is talking about exponents. That is, the left hand side is not dealing with an exponent, but there's something very important here. How do we change this? This here. How do we change that to be, to have an exponent? We can change exponents into roots, and we can change roots into exponents. There's a law in exponents and roots that says that. Remember, there's a 1 there. It's not written. So this left hand side can be equal to x to the power of 1 over 3. Maybe you didn't know that. Maybe this is fresh news to you. Let me just, on the side note, if I had square root of x, you can rewrite the square root of x. The mic is hurting your ears. Thank you for telling me. No one is saying anything. Let me just, on the side note, if I had square root of x, you can rewrite the square root of x. The mic is hurting your ears. It's not written. Let me just check quickly the audio. So this left hand side can be equal to x to the power of 1 over 3. Maybe you didn't know that. Maybe this is fresh news to you. Let me just. Okay, sorry about that. Let me just check quickly the audio. Testing 1, 2. I need to get a new mic, eh? Okay, sorry about that. Okay, guys, just keep communicating to me if the mic is if it's hurting your ears or not, but I'm gonna talk better now. Okay, so if I have okay, if I have square root of x, I can rewrite the square root of x to be 1 over 2. Yeah? maybe you didn't know that. Parabola, I'm getting there. I'm getting the sense of parabola is, you see, I'm here now. It's next. It's next on the list. Then I want to get to this one. Where is it now? Yeah, here is it. I'm gonna do this one now. Okay. So let me just finish this quickly, and then I'll get to the parabola. How is my mic there? Can you guys just let me know if the mic is still causing problems or not? So if I have, okay, example, square root of, if I have a 4 there, and I have x to the power of 3, no? There's a rule that says, this you write it as an exponent, 3 over 4. There's that rule there. Okay, get back to this. That is why I'm rewriting it like that. Okay, that is my left hand side. Remember when you're proving something? Okay, shut. When you're proving something, you're going to find left hand side, you're going to find right hand side. And you simplify both sides. So, my right hand side, this is the same basis. We're multiplying. So, what do I do with the same basis? If I multiply, I add the exponents. So, 2 over 9 plus 2 over 18. Do you see that? But I can simplify 2 over 18 to be 1 over 9. Yeah? Simplifying it. So now that I have 2 over 9 plus 1 over 9, right? Now that I have the same denominators, I can simply add the numerator. 2 plus 1 is 3, and the denominator stays the same. Then I simplify that fraction here. You see? And it's going to be 1 over 3. Therefore, left hand side equals to right hand side. Let me just highlight for you. There it is. And there it is, the right hand side. Okay. Just for you, Senzo, I'm going to go to parabola now. I'll skip the rest of the other stuff. Here is parabola here to the others. This is also a nice one. I'm going to come back to this. But for the sake of Senzo, he wants to do parabola. Let's go and do parabola. Okay. Take this whole thing here. It's just like this. Let's go to parabola for Senzo. Oof. Okay. So the graphs f of x. Let me just highlight here. F of x. Let me somehow highlight f of x as graph. So let me highlight it. That's the f graph. Then let me highlight g of x is this graph here. Yeah. Again, just to summarize what we're doing, we're going to question 3, but this is from the Limpopo paper of 2023, paper 1 from Limpopo. Okay, question 3. So those are the two graphs that sketched below. A and B are the x-intercepts of f. C and E are the y-intercepts of G and F respectively. Okay, the graph of G intersects the x-axis at A. F and G intersect at D. R and G lie on F and G respectively. Okay, let us head into it. 3.1. What are the coordinates of C? There is C. Yeah, there is C. Do you see? C, can you all see where C is? Can you see where C is? You see C? C is at the y-intercept for the G graph. So the coordinates of C is the y-intercept of the G graph. So the G graph, or the straight line, is equal to x, yeah, plus plus 2. Yeah? Since it's that C there, that C, you see, it's at the y-intercept. For me to find y-intercept, I let x equal 0. Yeah, because that's the way. So I have this. We know g of x can also equals to y. Now it's 0 plus 2 equals to 2. So the coordinate of C, this y-intercept here, is 2. That C there is 2. Yeah. So the coordinates of C, however, you must note that x is 0. You write it like this, comma 2. So this will be the coordinates of C. Do you see? Yeah? Okay. How's that Senzo? Let me know if things are going good. Okay. You can pause that. I'm gonna erase it. Okay. Now, the coordinates of A and B, what you need to understand is that A and B is this point over here and that point over there. Do you see it? That is the x-intercepts of the F graph. So A and B are the x-intercepts of the F graph. So let's take the F graph. The F graph is equal to half x squared minus 2. Right? So I know that is the x-intercepts. So I know for x-intercept it's equal to A and B. We let y equal 0. So then I have it's not changing. 0 equals to half x squared minus 2. Gonna solve. I was struggling with 2024 past paper question 4. Send it in the group there, then I'm gonna do it. Send it in the group, then I'll do it. Okay, so what I do then, I take the 2 over. I have 2 equals to half x squared. Now for this one, I'm going to get rid of the half. So I times by 2 on both sides. See that? So I have 4 equals to x squared. Now to solve for x, I'm going to square root both sides. And it's important to note, when you square root a number, the answer is the positive and negative of that. So I know, because a is on the left hand side, that is the negative 2, 1. And because b is on the right hand side, that is the positive 2, 1. So the coordinates for a is going to be negative 2. The y coordinate is 0 since it's an x-intercept. And for b, it's going to be 2, comma 0. Hope that is fine there. That is that answer there. Yeah. Okay. Let's move on to the next question. Okay. Determine the coordinates of the, there's a lot of things going on here. Let me just determine the coordinates of D. Now we have to see that D is actually where the two graphs, can I use green? D is where the two graphs intersect. So to find the point where the two graphs intersect, now we need to find D most now. When you want to find the point where two graphs are intersecting, you have to let, you're going to let f of x equal g of x. Do you see that? And you're going to find the coordinates. So you let the two equations equal to each other. So you're going to say half x squared, I'm so tired, minus 2 equals to, and sec x plus 2. Those are the two equations. You let them equal to each other of the graph. I'm going to take the x. In fact, because there's a 2 here, I know that there's going to be a trinomial. So I'm going to take everything over to the left hand side. So I have half x squared minus x, I took the x over, minus 2 equals to 0. Yeah. Then I have half x squared minus x minus 4 equals to 0. Okay. Now, I like to work with nothing in front of the x squared. So what I'm going to do, I'm going to multiply everything by 2, by 2, by 2, by 2. Because it's going to be difficult for me to solve this trinomial if there's a half in front of the x squared. So the first one, the 2 cancels. This becomes 2x. That becomes minus 8 equals to 0. Again, I have to solve this trinomial. So I have x here, x here. I can either choose the factors of 8 to be 8 in 1 or 4 in 2. I'm going to choose 4 in 2 because that relationship will give me the middle term. I'm going to choose the 4 to be negative, the 2 to be positive. Okay, I'm just going to move faster with this one. Right, then I have x minus 4 brackets, and I have x plus 2 equals to 0. Yeah, now I have again 2 answers. Now the reason why I have 2 answers, let's have a look at this quickly. Because the graph intersects at 2 different places by A and by D, the 2 graphs meet. That is why we have 2 possible answers coming up shortly. So we have x equals to 4 or x equals to minus 2. Now, there's 2 answers here, but we are working with D. We know that since D is on the right hand side, we know that the x will be positive since it's on the right hand side. So we know that this is the coordinate of D, the x coordinate of D. Do you see that? So to find the y coordinate, you need to substitute either into g of x or x of x. It doesn't matter to find the y coordinate, but it is easier to substitute it into the g of x graph. So y equals to, I'm going to use the g of x graph, is equal to x plus 2, if I'm not mistaken, and then you simply substitute the 4 in there. It's equal to 6. Okay, now you have your coordinates of D to be 4 and 6. I hope that you understand. This, it's guaranteed they're going to ask a question like this. I will bet everything that I have, they're going to ask a question where the two graphs meet. Guaranteed, you're gonna see something like this for sure. All my money on this. Okay. The range of f. The range of f. The range of f. Okay. Hope you understood this here. 4 and 6 is the coordinates of t. Almost done, and then I'll take any other questions. Send me that paper there on the group Senzona that you're struggling with. Anyone else struggling with any other papers that's not in any of my groups? Please, what you call it? Send to my email. Bootlock, if you are still here, send an email to my email, then I can email you grade 9 past papers. Okay, 3.4, the range of f. Again, f is the yellow graph, which is the parabola. What does range mean? Where does the graph exist? Vertically. Okay, now we can see that this graph of f, it turns here at e. So we can't say, oh, y is an element of infinity, element of all real numbers. No. No, it goes from e, right, all the way up to infinity. Okay, so we need to find what is e. How will I find what e? E is my y-intercept of my f of x graph. So you're going to let x equals to 0 to find the coordinates of e, my f of x graph. I'm going to say y equals to half. I'm going to substitute 0 in there, squared, minus 2, y is equal to minus 2. So I know the coordinates of e is minus 2. So the range, the graph y, okay, is an element of, sorry, not an element of, y is bigger or equal to minus 2. That's how you put it, like that. Or you can put it, y is an element of square brackets, because the graph touches -2, comma, up to in positive infinity, circular brackets there, because it cannot touch infinity. It's going all the way up there, all the way up. So you can either write it in this, or you can write it like this. Okay. This is an interesting question. I know most of you are not going to get this one. Yeah. For which values of x will g of x be bigger than f of x? Now, what is this saying? What is this here? What is it saying? It's saying, where will the graph g of x be bigger than f of x? It is saying that where will this graph be above? Where is the g of x graph? Above the f of x graph. In other words, where is the blue graph above the yellow graph? If I look here, what can I use? If I look here, if you look here, do you see that? Which graph is on top? The yellow graph is above the blue graph. Yeah? Do you see that? There's the yellow graph. There, down there is the blue graph. You see? But they're asking g of x. Where is the g of x graph, which is the straight line? Where is the straight line above the parabola? As you can see, starting at this point here. This point here. Do you see? From that point up to, do you see? Up to that point there. The blue graph is on top of the yellow graph. Do you see the yellow graph is there at the bottom? Do you see that? So this is asking for which values of x, where is the straight line graph above the parabola yellow graph. So it from A, from this point here, you see, from A up to this point which is D. Yeah, I've covered the D now. This point here D. So from this point A here, you see, in that entire space up to point D, the blue graph is above the yellow graph. So g of x, you write it like this, bigger than f of x, okay, where you're going to put. Now remember, it doesn't go on forever. It's in between A and in between D, because after D the yellow graph goes above the blue graph. Do you see that? So it's only up from A to D. We know that A is -2, so x is in between -2 and D. What was the coordinates of D? Oh goodness, guys, what was the coordinates of D? 6. Was it 6 or 4? Can someone please tell me the coordinates of D? Or I'll just go back in the channel, because people know when they respond to me. What was the coordinates of D? 4 and 6. Yeah. So D went up to 4. Yeah? So this x value here is 4 by D. We found it earlier. So this is what you're going to have for that question for 3.5. Okay. Senju, did you send that question? That question paper in the group? Yeah, I don't want to leak my WhatsApp now. Just give me 1 second. Isn't there a BRB scene? I sent a picture of the question. Shot it. Okay. I'll be right. I'm still here. It's blank. I know it's blank. I know it's blank, guys. I know it's blank. It's not load shedding. Just wanna go to my WhatsApp call. Okay, send a picture. Just going quickly to this picture. I know it's blank, guys. Where is this image? Download. Okay, got it. Okay, the quality is 4.6. 4.6. Okay, the corners. That's so delayed. The stream, not you. The stream. Okay. I'm back, guys. I'm back. Okay. So consider the functions. F of x equals to ax squared plus gx. F and g intersect at points -1 and 3, -3. and B 2 and 0. Calculate the values of A and C. Okay. Let me say, let me just visualize. I like to visualize, yeah? So they intersect at -1 and -3, which would be around here, around there. I'm just drawing a rough graph. And they intersect at 2 and 0. Let me just make this a different color. And they intersect at 2 and 0, no? 2 and 0, which is here. Yeah? I'm using it. Is that an ad? Just give me 1 second, guys. I'm just quickly. Okay. So, right. I know that one is a parabola, one is a straight line, and they are intersecting there. That means, if that's where they intersect, that means there's a straight line going here. It's 2 points. So what I have, Senzo, you see why I visualize things? I have this, I can call, I know that this is my g of x graph. I know it's my g of x graph. You see? Ah, I'm getting robbed live on stream. Okay. So this is my g of x graph. Okay. Now, if I can visualize my f of x graph, it has to look something like this. My f of x graph. Okay. Now, I'm not even answering the question. This is the estimation of my graph. Yeah? To help us visualize what's going on here. I drew the 2 points and I know more or less, since it's a positive, okay. Or the graph could actually also, the parabola graph could also be like that, depending on whether it's positive or negative. Nah? But I'm gonna keep it like this for now. So we need to determine the values of A. We need to determine the values of C, which is this over here. Our last lesson, I called you guys in for 20 minutes. Showed you how to find an equation of a parabola when you are given 2 points. Do you remember that? Do you remember that? How would you do that? Or can you find that for me? The equation of a parabola. There's a way to find it. Type it in the chat. There's an equation that I gave you guys. Let's see if anyone can get that. Let's see. Anyone? I'll give you guys time. Finding the equation of a parabola from 2 points. You should know. This is a nice thumbnail, by the way. Substitute a point in the formula. There's another way. There's another one. Okay, let's try your method now. But there's another way. There's another way that I taught you guys on the last day. On the last day. Let's substitute. Let's see what we find. Because, in fact, no, we can't, because there's going to be 2 unknowns. Even if we substitute x and y. There's going to be 2 unknowns. What's that equation? It's there somewhere, guys. Don't be lazy. I'll give you about 10 seconds. Not 10, 30 seconds. See, people are leaving now. There's an equation. That is y equals to x squared plus. No, that is this equation over here. Okay? That is that equation over there. So, this equation, even if I substitute in there, I'm going to have still 2 unknowns. You understand? So I cannot use that equation there. What equation am I going to use? And Dinako, very close. Very, very close. That equation is for x-intercepts. Yeah, Senzo. that equation, I wanted that equation. That equation is when you have two x-intercepts. Do you see? You only have one y-x-intercept here. Do you see? So, what we're going to do, okay, substitute both points then simultaneous. Yes, we are going to have to do simultaneous equations. Okay, so I love it. Who said that? Miles, where have you been? Miles with the clutch answer for the chat there. Okay, so we're gonna do both points. Let me just zoom out here over it. We're gonna do for f of x, we're gonna have ax squared plus c. Okay, Miles, that was brilliant, by the way. Are you in my class? Ish. Why are you laughing? The first point a, okay, I'm gonna substitute in there. So I'm gonna have minus 3 equals to a minus 1 squared plus c. Is this for further maths? No, this is grade 10. Miles is not in my class. Ish, I'm not a good teacher. Okay, so I have minus 3 equals to a minus 1 squared is just 1. So it's a plus c. Okay, this I'm going to call my equation 1. Yeah. Then, Miles, are you in grade 10 though? But anyways, it's fine. We'll move on. That's my equation 1 when I substitute the points of a in here. Minus 1, minus 3. Now I'm going to substitute. I'm going to do this in the color red. I'm going to substitute the points b, 2, and 0 into that same equation. I have a further maths exam tomorrow. I'm going to cry. Yeah. You can cry in the chat. It's fine. You can cry. What topics do you do for further maths? Are you referring to university maths, or is this not even from South Africa? Because I don't know anything. Are you referring to further maths as AP maths or what? I don't know. Okay, I've substitute the point b in there. My y is equal to 0 now. Then I have a, my x is equal to 2 squared plus c. Yeah. Now I have 0 equals to 4a. Yeah, 2 squared is 4 plus c. Now, mocks next week, I might be cooked for real, for real. Yeah, don't stress. But you have a whole week to prepare. You're gonna be fine, man. So I have my first equation. Why is it so? I have my first equation here, which is minus 3 equals to a plus c. And for my second point, I have a different equation. Over here, 0 equals to 4a plus c. This is referring to my second equation. So I'm going to say the equation 2. So again, this is simultaneous equations. So we should know how to solve simultaneous equations. So I'm going to say from equation 1. Yeah. I'm going to let a, or at a or c. Yeah. I'm going to let a equals to minus 3 minus c. You see this first equation here? I just solved for a. Okay, so now I have a there. Now what I do, I substitute 1 into equation 2. Then I have 0 equals to 4 brackets minus 3 minus c plus c. So I'm going to solve for c here now. Yeah. 0 equals to minus 12 minus 4c plus c. I'm going to take the 12 over. 12 equals to minus 3c. Then to find c, I divide by 3 on both sides. Sorry, negative 3 on both sides. So I have negative 4 is equal to c. Do you see that from my estimated graph? Look here. Look at that. So I can see that c is equal to negative 4. And my estimated graph is correct. So I can sense that I'm on the correct track there. Okay? But I have to also find a. So I know that if I look here, yeah, do you see that there? A is equal to minus 3 minus c. So what I'm going to do simply, a is equal to minus 3 minus c. That is equation 1. Remember that, no? It's equation 1. And to find a, I substitute my c that I just found out in brackets minus 4 like that. So a is equal to minus 3 minus minus 4. That's going to be equal to 1. Okay. So now my a is 1, my c is minus 4. So my f of x is equal to, it's just going to be 1x squared. I'm just going to write x squared minus 4. That's my equation of my f of x graph over there. Okay. We have to find now. Okay, sorry, let me just, yeah, that's how you found a and c there. Yes, Senzo. I hope that you understood that there. Took us a while to get here, but yeah. Okay, right. All of that erase. Just gonna erase all of that. As we have A in C. Okay, gonna erase it. Erase that. I'm just gonna keep the equation there. It's gonna come in handy later. Okay. Right. Now we need to find P and Q. Now, similarly, we have g of x equals to px plus q. Again, we're gonna just do the same thing now. We're gonna substitute the point A in the also simultaneous equations. I wonder if there's a quicker way. There is P, this P here is the gradient. No, it's always the gradient in front of the x. So we can find the gradient here. And then after we find the gradient, we can substitute in a point to find Q. Would that be easier? Faster? No, it's fine. Let's stick to the simultaneous equation. So I'm going to substitute A. So it's minus 3 equals to P minus 1 plus Q That is equation 1. Okay. Can't we can? You want me to show you? I can show you. To find the equation, to find B and to find Q of this graph here, we can use the gradient. Because gradient is equal to y2 minus y1 over x2 minus x1. Because keep in mind that this point A and this point B are points on the graph. So I can use those 2 points to find the gradient. You with me? Just for your sake, I'm going to do the gradient one now. So y2 is 0, minus y1 is minus 3. Do you see that? You're going to get to the same answer. Come, I show you. Then x2 minus x1, like that. So that's equal to 3 over 2. Now, keep in mind that that is p. 3 over 2, now. Let's keep that in mind. Okay? Now, let's carry on with what I was doing. It has to be 3 over 2, Senzo. Any 2 points on a straight line is always the number in front of. Yeah. Then I can find Q later on. Yeah. Gradient won't just solve to the 1. But anyways, remember now the gradient was 3 over 2. I'll just prove to you by doing it both ways. So that's equation 1. Then I'm going to use point P, which is 2 and 0. Come now. My brain is lagging. Substitute 0 in there. Then I have Px is equal to 2. So I'm just gonna put the 2b, yeah? Plus q. That's equation 2. Yeah. So I'm gonna take the 2b over. I'm gonna let it equal to q. Yeah. That's my equation 2 now. My new equation 2. My new and improved. So I'm gonna substitute 2 into 1. Yeah. Okay. So then I have minus 3 equals to minus b. B times minus 1 is minus b. Yeah. I'm just writing that one like this for faster working purposes. Okay. Then plus q. Q, remember, is minus 2b. Okay. Did I make a mistake somewhere? Okay. Then I have minus 3 is equal to minus 3b. Okay. Then I divide by minus 3 on both sides. B is equal to 1. What? I think I did the gradient wrong. The gradient is also 1. Come, I do the gradient again. y2, which is minus 3. No, sorry, 0. So y2 minus minus 3. Now I'm just going to do the gradient one again. Right? Then x2, which is 2 minus minus 1. Ne? So that gradient is equal to 3 over 3, which is equal to 1, which I said the gradient is equal to b. So you can see there that it is the same answer I was about to say. Yeah, my earlier gradient is wrong. My earlier gradient is wrong. This way I did it now, I don't know what I did earlier. I must have made a mistake. But yeah, I did the gradient formula properly and it gives me 1. I must have made a mistake in the earlier calculations and no one said anything, which is very sad. Very, very sad. I was testing you guys and everyone failed. Okay. So yeah, this is the new or my corrected way of calculating the gradient here, Senzo. Do you see? So either you can use the gradient. I'm 100% certain of that. You can use the gradient, but we're not done. We only have b. Job's not done. So now we have what is it? G of x. B is 1. So it's equal to what is it? Bx plus q now. So now I have, remember g of x is y equals to x, since b is 1, plus q, and I need to find q now. So I can substitute any point in here to find q, or I can put this 1. Do you see here this equation over here? It says q is equal to minus 2b. So I can put this 1 in there. So q equals to minus 2 brackets 1. Q is equal to minus 2. So the equation here is x minus 2 for the g of x graph. And it makes sense because look here, there, that point there, this point here is the minus 2. Let me just highlight it quickly. Here would be minus 2. I'm going to use purple. There would be minus 2. Okay, that would be the minus 2 there for that graph. Yes, you can. Is it positive 2? No, it's negative 2, ne? It's negative 2 cents. So yes, you can say that. You could have said that as well. But yeah. What you have in the chat is correct, but then you solved for Q wrong. You have in the chat, not wrong, it's a mistake. I know you made. I know you know the mistake. You have this in the chat, which is correct. Then you take that over, it's minus 3 plus 1 equals to Q. So minus 2 equals to Q. Then it's correct. Yeah, that too. That too. But Q is negative 2. Q is negative 2. So then when you draw your graph, yeah, this here is minus 2. Yours is minus 4 here. That's minus 4. We found it out earlier. Our x-intercepts, we need to indicate our x-intercepts as well. So for this f of x graph, I can calculate the x-intercepts in my head. Okay, let me not do it in my head, it's fine. It's 4 equals to x squared, and you know that it's going to be plus minus 2. So the x-intercepts here is going to be minus 2 here and 2 there. Which you already know because that's p. Okay, and then this here is going to be, this here is going to be minus 1 minus 3 because that's a. See, I hope my graph is fine. Should I do the graph properly, or do you see it right there? Let me know if you want me to draw the graph properly, professionally, or do you get the rough idea of the graph? I'll just wait for your response in, so it's gonna take a few seconds. Last one. In fact, I'm gonna have to draw the graph properly now. Can you do 4.5 also? Because you say last one, which means you can do 4.4. Okay, let me erase everything how you're out the way. Just gonna erase everything. The keys. Just gonna erase everything out the way quickly. Okay. Graph is fine. Thank you, Senzo. Thank you. Okay. So, firstly, determine the value of g of x minus f of x. Determine the values of g of x minus f of x. I think you know what to do there. You have a suspicion on what to do. Simple. Determine the value of g of x minus f of x. Okay, okay. I don't want to keep delaying and waiting for responses. Okay, all you do, you take g of x. What was g of x equals to? G of x was equal to, what is it? X minus 2. So you take g of x minus 2, and you subtract f of x, which is equal to x squared. But you must put brackets now because you're subtracting the whole graph. That is equal to x squared minus 4. You see? That's it. And then the minus, you multiply it in there. X minus 2 minus x squared plus 4. Yeah? Can you be left with? I'm going to put the minus x squared here plus x plus 2. That's your answer. That's it for 4.4. I realized how small this is, but that's what the question is saying there. Gx minus f of x. Yeah. And then we did this over here. We just take the graph's equation and you minus the first one. G of x minus f of x. But the brackets is important. Always. So yeah. I'm getting the hang of this OneNote thing. I'm going to do 4.5 for the sake of everybody else as well. Gx, determine for which values. We just did one similar to this. Yeah. Yo. This one. Similar to this, we did it. They want to know where is Gx bigger than f of x. Right? I explained it now, but I know I don't want to now ask you guys to give me the answer. Where for which values of x is g of x bigger or equal to? That's very different to just bigger than. That one just said bigger than. This one says bigger or equal to. No, but it's just a slight difference. So where is g of x bigger or equal to f of x? I'm gonna wait for chat. Now tell me, Senzo, if it's fine, tell me. Help everyone here, everyone else that's watching. Help us. What is g of x? For which values is g of x bigger or equal to f of x? What do we look at? Let's hope Senzo helps us out here, guys. Hopefully, he didn't leave. Why does my thing say 8 and 9 mathematics? Supposed to say grade 10. And I'm done with the stream basically. Hey, silly mistake. Let's hope Senzo is not okay. It's fine. Senzo might be gone. Okay, so we look at g of x, which is the straight line. Where is it above f of x or equal to? So we're gonna include. Oh, my highlighter is cooked. What color can I use? Green, red. I'm gonna use red. Yeah. Can I make this bigger? I'm gonna make it massive. So at this point here, they are equal, where x is equal to -1. And here they are equal, where x is equal to 2. Can we see that? Anyways, no one's gonna respond. Now, where is this g of x graph bigger? Which means where is it above? So as you can see, from this point A all the way to that point D, it's above. Do you see where is the green graph, which is f of x? F of x is below there. You understand? So from this A, this point A, to the point over here, where this is 2, which we found out earlier, we can say that it is in between the -1, which remember they say determine the values of x, yeah, which is -1 and 2. So it's in between -1 and 2, because before -1, do you see that the green graph is above the blue graph here? And after 2, the green graph goes above the blue graph. So only in between -1 and equal to 2. This is how you write it, like this. Okay, so -1 and 2. Unlike here, do you see here that we did just in between? There was no equal to. We didn't put equal to because this here didn't have equal to. But it must include equal to, no? Okay, you did. Yes, Senzo. Beautiful. Okay, so that is our answer there. Yeah. Any other questions, guys? There's another question I didn't do here. This one here. Are there any other questions for this one? Any other questions you guys want me to do? Any other past papers? I think I'm going to end it off here. Any questions you guys want to ask? How long did I stream? Am I streaming for 2 hours? Thank you for the responses in the chat, guys, for responding. Very hard to teach when no one's talking. So yeah, I think I'm gonna call it D. No one has any other questions. You're gonna get me monet. Gonna get me striked, yeah. No questions from me. Thank you for taking time to teach at this hour. It's a pleasure, Miles. It's a pleasure. Um, Thank you for tuning in and responding as well. Trying to think I didn't even use this calculator whole session. That's crazy, guys. You don't need to bring a calculator tomorrow night. Don't bring a calculator. Try. Try and do it without a calculator. The whole exam. That's crazy. You don't actually need any calculators for any of this. Yeah. Imagine a calculatorless exam. You sent another question on the group to Uncle Senzo. And let's go look on the group for Senzo's other question. Senzo's only. I hope that you only. No. Don't worry about him. He's not coming. That is an exponential graph. Don't worry about him, Senzo. He's not coming in. According to the scope. Where is the scope? According to the scope, there is no exponential. It says parabola in straight line, then it says parabola. There is no exponential. That is the. What was that? Oh, thanks, Miles, for subscribing. I forgot that it does that. Yeah, my Senzo, that is an exponential graph. We're gonna do that. We're gonna do that after this term. Yeah. Normally that exponential graph is in the paper, but I think the entire province must be behind. Not behind, but slightly behind, and not couldn't get to exponential graphs. Okay, thank you guys for tuning in. Thank you for watching. I'll see you guys maybe tomorrow again live, and then paper 2 I'll see you guys again. If there's no other questions. Yes, Nelizwe Pango. What's up? Is it a question you have there or what? You can ask any other grades as well. So Nelizwe, sorry. So if there's no other questions, I think I'm gonna end it there. Okay, let me do. Let me just look for some questions. I'll go a bit a few more hours. Let me choose one. Let me choose this one here. Let me choose this one. I'll do 1.2.2, 1.2.3, then I'll be done. Okay. So we have this over here, x squared minus 5x. Okay, I remember most of you guys lost marks in this. Okay, so we have x squared minus 5x over x cubed minus 25x divided by 4x minus 6 all over 2x squared plus 7x minus 15. Okay. So firstly, I'm going to change the division sign to a multiplication. Yeah? But let me also factorize at the same time. You guys are grade 10, I can do two things at once. So this top here, I'm just going to highlight it. This top here, common factor, easy, easy, easy. Common factor, 3 marks. So x comes out there, bracket, x minus 5, close brackets. Okay. Okay, that's the first one. Wait, can I just separate this quickly? Right. All of that over, again, here is common factor. Okay. So, come on, man. So I take out the x there as well. There's a common factor of x, bracket, x squared minus 25. Okay. You can already see what's going to happen there. Multiplied by, since I'm multiplying, this numerator is now going to be a denominator and the denominator is going to be a numerator. So this 2x squared is at the top plus 7x minus 15, all of that over 4x minus 6. There's a common factor of 2 brackets 2x minus 3. Huh? Yes. Okay. So I'm still not done. Exponents, please. Okay. I'm going to do exponents straight after this one somehow. Okay. Oh, the next one is exponents, I think. So this over here, the top, there's nothing I can do here on the top. Let me just highlight. Here, nothing I can do. I'm going to keep it like that. Nah? The next one below that, I can factorize even further. Okay. So I'm going to keep the top as it is. Okay. And the bottom I can factorize because x squared minus 25 is difference of two squares. So I have x minus 5, x plus 5. I can already see cancellation happening. Okay. Times. This top here is a trinomial. Okay, so what I'm going to do, I'm going to do this trinomial separately. 2x squared plus 7x minus 15. X here, so it's 2x on the side, x on the side. I know some of you are not familiar with this one. Now I can choose a variety of options. I'm not going to choose 15 and 1. I'm going to choose 5 and 3. I'm going to choose 5 here and 3 here, because when I go across like this, I get 10x. When I go across like this, I get 3x. 10x minus 3x is this middle term here. That is why I'm choosing the 3 and the 5 in that specific position. I'm going to choose since the middle term is positive, I'm going to choose the bigger one to be positive here and this one to be negative, because remember I must still get negative 15 when I multiply these two here on the side. Then I'm left with 2x minus 3 brackets x plus 5. So I factorize the top. Nah? So here it is 2x minus 3 and x plus 5. You can already see a lot of cancellations happening here. When you see that, you can smile nice. If I don't see anyone smiling in the exam, then I know no one is cancelling anything. Okay, now I can cancel. I'm gonna take my red, my purple highlighter and cancel. So that can cancel. That can cancel with that. The x plus 5 cancel with the x plus 5 here. The 2x minus 3 cancel with that 2x minus 3. That x cancel with that x. Look how beautiful that cancels out. My goodness. Have you seen the like? So this is 1 over 1 times 1 over 2. That's equal to 1 over 2. That's the final answer. Beautiful. Okay. So after that cancellation happening there, it's like there's only few things in life that give you happiness, and that's it right there. That's why you do maths. Okay, let's go to the exponents, Enzo. This one here. It's looking feisty. Okay. I already solved it in my head. Okay. So 5 no, to the power of 2n plus 1 dot 3 of 2n minus 3. Nothing I can do with the 5, nothing I can do with the 3. Those are bases that I can do nothing with. But this 15 I can change. Now, in the exam, when you're working with exponents, you want to have bases that are the same. Now, with the base 5 and the base 3, there's no way you're going to make the base 5 and the base 3 equal. So there's nothing you can do there. But the 15 is a problem. The 15 you can make the base different. So you can change 15 by pressing in your calculator 15 equals shift fact. 15 can be changed to be 3 times 5. Isn't that beautiful? So you have 3 times 5. Very important to put that in brackets. 2n. Do you see that? Now you can rewrite this. We have 5 2n plus 1 dot 3 2n minus 3. Our exponent rules tells us this, that this 2n multiplies in there and it multiplies in there. So then I'm going to rewrite this to be, I'm going to put the 5 here. It doesn't matter where I put the 5, the order. So 5, wait, let me write. So I have 5 to the power of 2n dot 3 to the power of 2n. The reason I'm putting it in that order so that the 5 can be underneath the 5, but the order doesn't matter. Okay, that equals to same basis, 3, 3, 5, 5. Beautiful. I'm dividing. When I'm dividing and I have the same basis, what do I do with the exponents? I subtract the exponents when I'm dividing the same base. So I have 5 to the power of 2n plus 1 minus 2n dot 3 minus dot 3 2n minus 3 minus 2n. That's equal to, here by the 5, the 2n minus 2n will go away. So I'll be left with 5 to the power of 1 dot, again 2n minus 2n goes away here. That goes away. I'm left with 3 to the power of negative 3. You see that? Beautiful, the ends are gone. So then I have 5 to the power of 1 dot 1 over 3 to the power of 3. Remember when the exponent is negative, I can put the exponent at the bottom as positive. So then I have 5 over 3 to the power of 3, which is 27. That's done there. Okay. I hope that was good. Yeah. La 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 la. Let's look at my canvas. Oh, it's not that big. Let me see if there's another exponents question. Anything here you guys want me to do? Okay, I think I'm gonna call it there. Anyone else needs help? Check on the group. Thank you for joining. Peace. Thanks for watching. Bye, guys. Bye bye. See you. Bye. Bye bye. Good luck for the exam tomorrow. Good luck for your exams always. Yeah.